It's Sunday, the 18th of May. Today, we're winding down, uh, getting ready for week 7, which will start well, Monday, I guess, a holiday, but no holidays for us folks, I guess. Work when we can and study when we can. Uh, I'm going to just pull up the week 7 uh, module and kind of click around and talk about the things. There's a lot in here, as you can see. We've got a tailgate down here, a little fodder for the tailgate. The tailgates are getting harder to. I have one of our students who's been with us a while. Like I'm asking him his response, and he didn't have a response, and I can understand that. But I want you to really, really push yourself or dive deep, ask questions. I sent him back an email with, questions I have. I just read these rules, I don't put them to memory, but after going through them so much, I've gained a little bit of ground on, what's in my mind now and there maybe to stay. Uh, this has been a uphill climb and we're not through yet. I think it's going to get a little, maybe, I don't want to say better, uh, but we've got, what, 3 weeks to go, and doing my best to make it interesting. It's all important. There's no doubt about that. I've learned a couple of things myself along the way. Hopefully, you will too. So, I don't want to take up a whole lot of your time, but I want to give you like a heads up on what's coming up in week 7. Let's just start here. It says video, but this is the video, I guess, that we're doing right now. So I'm going to open that up. Look at the overview here. Contains information related to the different types of protective systems. Let me get me some water right quick. I haven't figured out how to pause this or mute myself. I guess I probably could if I took the time so I could, if I get distracted, I can mute, pause, whatever. I know it will. I just haven't got to it. So by the end of the module, you, the student, will be able to, I hope, identify and describe configurations, should be plural, there's more than one, of different sloping and benching system based on trench requirements and soil type. So now what I know of, if it mentions benching and sloping, I know that we go to paragraph C, and then there's going to be 4 options for designing benching and sloping systems. Now that I've been stuck inside that rule, so I know it a little bit now. Uh, let's see, identify types of shoring systems. That would take us to C, uh, paragraph C, and it has 4 options. Their variations and state their application as applicable to existing conditions. Today, uh, we're going to be looking at uh, aluminum hydraulic shoring systems, vertical shoring systems, and those are actually I want to say an alternative uh, to the benching and sloping. So identify some shield systems. Of course, those are trench boxes and their configurations and applications. I didn't spend a lot of time on trench box shielding as much as I did on shoring. Shoring has a little bit more different pieces and considerations. I say that with caution because trench shields have to be designed uh, and are signed off by an engineer. So does the shoring. So both when used as a single protective system or in conjunction with other systems such as sloping. In other words, we'll see a picture of a trench shield or trench box in the bottom of a slope ditch uh, so that the slope didn't have to go down uh, as far. Demonstrate understanding of the requirements for tabulated data. Tabulated data is a really big deal. Watched a long uh, it was a workshop or something that NUCA, National Utility Contractors Association, in conjunction with United Rentals, put together, and it says like 46% of the people that were surveyed had problems with understanding manufacturers' data, shoring or shielding data. The manufacturer, when they build let's say a shoring system, they're going to have all of the designs. Uh, they're going to build a system in accordance with different kinds of ditch configurations, depth, they consider that, and of course they'll consider the forces and all of those things. But the tabulated data is to give you a table to look at. So if you look at that table and you're digging a 10-foot ditch that's uh, 4 feet wide and it's in Class A soil, they're going to have stipulations about the cylinder spacing, the hydraulic cylinders, how far apart those things are, and even a staggered situation that we'll see on vertical shoring where they're pushing up against the trench wall and some are down a little bit low and some are a little bit high and just up and down along the trench, and we'll see a picture of that. So the not the I guess that this module is probably more about tabulated data than anything else. Because my tailgate is about tabulated data, but I do have what I call tailgate fodder thrown in here because there is a lot of information. And the last tailgate was I kind of left you hanging there with trying to come up with something. But I'd like to see for effort. Don't look at something and say I don't have a response. Uh, well, say it if you want to, but don't tell me. Come up with a response is my advice. But we move on. So let's get out of this overview. And the way I do it is I go up here, right click, go to the modules, and I usually end up pretty close to where I want to be. There's the overview. And here is, I think do we have a video in here? We do here. What is it? Well, let's just look and see what's in here. These are instructional resources. What do we got in here? Yeah, we got a couple of videos. This is a trench box and aluminum hydraulic shoring. I won't go through those now, but here's your video for the hydraulic vertical aluminum. Really is what we use in vertical shoring. This video down here, it shows a video and putting the trench box together, I think, and then picking it up and setting it in. You'll need an excavator around when you start setting these trench boxes in the trench. Okay, let's go see what's next. Let's see where I come out. This right here is interesting, I think. National Trench Safety. Uh, National Trench Safety, that's a company. And the guy that used to work for them, founded the company, is Joe Turner. And he's kind of the guru of trenching and shoring. Actually, he's the one that wrote this textbook that we're reading from. He's been in this business a long time out in Santa Rosa. There's a couple of companies out in Santa Rosa, California that build shores. So I want to open this up and show you what's in here because there's going to probably be some questions about it. This is, let's see what I said in here. What is tabulated data as it refers to selecting the proper safety system for excavation? The manufacturer's tabulated data is a general set of guidelines and tables to assist the competent person in selecting a safety system and the proper shoring and shielding equipment. The competent person has sole responsibility for job site safety and the proper selection, installation, and removal of the shoring or shielding equipment. The tabulated data is not intended to be used as a job-specific excavation safety plan, a job-specific excavation safety plan, but shall be used by the competent person to supplement his training, his experience, and his knowledge of the job conditions and the soil types. For further information on what I'm talking about now, I want you to, when you get this, go ahead and click on this link that I have down here, and it's going to talk understanding the requirements a little bit better. Keep in mind, your tailgate's going to be about all this kind of stuff. So this will give you some resources. And I told you when I put that tailgate together is I don't mind you going outside and finding information as long as you don't copy and paste it. Put it to the best of your ability in your words and your understanding of what the article, or for instance, this, I don't know, this looks more like a brochure, not a brochure, but something you might carry around in case you need it. But so this is North American Excavating Shoring Systems. You can use this information. Notice though that understanding the requirements for tabulated data within OSHA Subpart P 1926-52 652, protection of employees in an excavation, the use of tabulated data is referenced through 26652A, and you go to 1 and you'll see it talks about tabulated data, and that's it talks about, that's where it says each employee in an excavation shall be protected from cave-ins by an adequate protective system. And that's what I talked to James, that was really surprising me. And the more I read OSHA, they don't hold their feet to the fire. They say adequate instead of being prescriptive. They're I forgot to call that. Anyway, I'll get back to that later. It's a really interesting concept. But they're just, instead of telling you what it's got to hold back, it just says adequate protective systems in accordance with B, which is about benching and shoring, or paragraph C, which is about like mechanical safety systems. Paragraph B refers to open cut systems, and paragraph C refers to manufacturing shoring systems. Look at that. I just said that. So B3, designs of sloping or benching systems shall be selected from and be in accordance with tabulated data such as tables and charts. Now here we go in these options. We've already gone through this, I know it, but I want you to be able to come to this and be able to see that this is where option not C is. This is where C is, which talks about systems. And here's the option 2, designs using manufacturer's tabulated data. Tabulated data comes in many different forms and formats. It is important to understand the basic elements and why they are there. All manufactured products that are sold for purpose and customer use come with manufacturer's tabulated data. There are 3 major elements. Please pay attention to these. You will need this information and more. Tabulation, tables and charts utilized to achieve a resulting number. For example, given OSHA Type B soil at 12 feet deep, what pounds per square foot rating does the shoring shield need to have? You know, that's going to be in there somewhere. I don't know if you need to know it because of the tables kind of take the place of having you have to know the pounds per square foot. But I think most of this stuff is rated at about 18,000. OSHA requires these calculated tables to be developed and stamped by a registered engineer. There are notes. Maybe there's some of you crane guys in here. You had lots of notes. You know, there was standard kinds of rules you followed, but then you would have notes to consider. Notes to the tabulation table. There may be additional requirements or key information. For example, in order to use these tables, the competent person must first determine the soil type in accordance with the OSHA Appendix 8, which I hope to get to as soon as I can. That's soil classification, OSHA style. Notes to tables are every bit as important as the tables themselves and must be read and understood by the person using the table. I know I've got an example or it's a problem in here for you to read a table and then tell me what size cylinders and things like that. It has notes, and it's an aluminum system, and the notes, one of the notes says in this case you have to use steel uh, cylinders with a jacket, they call it. In other words, it's a reinforced cylinder. The registered engineer develops the notes, and they become part of what the stamp covers. Uh, manufacturer's product information. That's important details such as a description of the product. That's a really big deal right there. Description of the product, its features, purpose, and appropriate use, the tabular form of various equipment sizes and weights, assembly, installation, and removal of the product, maintenance instructions, etc. This information is developed by the manufacturer and not necessarily stamped by an engineer. So this is like general information. It's just saying, look out for this, or be aware of the purpose of the MFTD, manufacturer's tabulated data, is the manufacturer's data, tabulated data, is used by the contractor to select the equipment, make sure the equipment is not being used outside its limitation. That's important. Not being used outside its limitation. Install the product and maintain all safety precautions related to it when in use. The engineering staff reviewing submittals use the manufacturer's tabulated data to make sure the equipment will meet the intent of the excavation and the requirements of the project. Project inspection personnel and OSHA use the tabulated data to make sure the equipment is properly installed. They'll come out on the site. You have to have that stuff out there on the site for them to look at. Other OSHA requirements relate to trenching, but inspection personnel should confine their requirements for the product use to what is given in the tables. If they wish to set other requirements outside the data, it should be clearly stated in contract documents so the contractor can incorporate the cost of those additional requirements into the bid. Also, if you change things without getting written permission from the manufacturer, all bets are off. If something happens, it's on you, the contractor, that changed it without checking with the manufacturer and getting his written permission. So the legal considerations is what we're leading up to. Federal OSHA requires that tabulated data, part of the manufacturer's tabulated data, be stamped by an engineer, by a registered engineer. It does not require that it be stamped in every state in the USA. Without getting into depth, interstate commerce regulations require that the singular state stamp be accepted for use across the United States. on and on here. See if there's anything. If it requires that it be stamped and engineered in that state, it should be clearly stated on the tabulated data. The bidding contractors can cover the cost of getting a local engineer to review the stamp, the data. The reasons for requiring a local stamp ensures that lawsuits regarding the product can be litigated in the state, ensures that the engineering work has been performed in accordance with state engineering standards as well as OSHA. It promotes full employment of engineers registered in that state. Helps them get a job. Is that what they're saying? Yeah. These are reasonable and appropriate concerns, and they are advantages the owner is entitled to specify in his contract. Let's see if the document shows that a stamp has expired. It does not mean the equipment that is being certified is any less safe. To be clear, an expired PE stamp, professional engineer, registered professional stamp on a document does not reduce the quality aspect of the product in any way. OSHA does not require the stamp to be current. Okay. So there is a reason for requiring a current stamp to ensure that the engineer and engineering firm is still available to engage with should there be questions. The source is limitless for tabulated data. Data development does not have to be limited to manufacturers. Contractors that develop their own shoring tools, methods, or procedures can have an engineer around, stamp it, say it's good to go. But be aware of the following restrictions. 52G2, additional requirements for shield system used in trench excavations. Excavations of earth material to a level not greater than 2 feet. Not greater than 2 feet below the bottom of a shield shall be permitted, but only if the shield is designed to resist the forces calculated for the full depth of the trench, and there's no indications of why the trench. So you guys aren't going to remember all this, and neither am I, but you are aware of it now, and you know where it's found, or at least you will now. The tabulated data are a design by an engineer cannot be override this requirement. The restriction says it in addition to, and that's in quotes. So, goodness, we made it to the end of that little guy. But that's important. I don't know if I have any questions coming at you. I tried to be, this is pretty much a one-way street. I get feedback in the form of, I think I have one assignment here. I'll get feedback from what you know. And by the way, on tailgates, I'm interested in what you know, not so much as how you convey it. I do want good grammar. I want your post to be engaging. Same thing applies, contribute to the learning community. All those things still apply, but I want to see what you know. Don't start telling me something's important. I want to know why it's important. If you say it's important, you must have a reason for saying that. I need you to tell me why. Don't just go through here rambling about how important things are. Tell me why they're important. So we've got, again, back to 3 major elements. I think we read that once before. I don't know how we got back to this. That's enough for that. So I'm going to get out of here. We're not done. A little bit longer video today. But what better way to spend my Sunday, huh? So right here we found that there is a video in here. I think I used to have it. No, here we found it. What's in here? Seems like there's a video in here. There's 2. Great. So you can look at that. Perhaps it'll add to what we've already talked about. So we've talked about this. Now here's Appendix D, aluminum hydraulic shoring. Tabulated data, getting started, kind of. I say it's a video. It's not a video. it's in this video, but we're going to look at it, and it's OSHA, it's in OSHA, Appendix D is in OSHA, and what it's going to talk about is, if you look at this example, it's going to have a scenario, and then it's going to tell you what you're going to find when you go to the tabulated data. They have tables. We'll be using D1, I think D2 and D3 for different kinds of soils, but we're not going to really be doing, this is just a show and tell thing that we're going to do right now. Let me open this up and see if I'm in the right place. I think I am. So remember, this is Appendix D, and there's no video in here. I was going to put one in here, but I'd rather just do it like we're going to do it and do it like you're going to see it. This appendix contains, okay, here's the title of it. It's not a video. Appendix D of Part 1926 Aluminum Hydraulic Shoring for Trenches. The appendix contains information that can be used when aluminum hydraulic shoring is provided as a method of protection. And now ask yourself, would that come under paragraph B or C? C. Protection against cave-ins in trenches that do not exceed 20 feet in depth. This appendix must be used when design of aluminum hydraulic protective system cannot be performed in accordance with C. In other words, what's C? That's all of the open ditches and the slopes. And no, that's the C is the actual protective system, mechanical system. And it also included are 5 examples for selecting components. And these are examples. They'll be in the form of a question, kind of a deal, but it's mostly show and tell. So let me get this open, and we'll kind of walk around inside this file and be as purposeful as we can. Here is Appendix D as it appears in OSHA. As you can see, it's the typical OSHA stuff going on here. I'm not going to read this to you. I would hope that you would look through here. Presentation of information. So it tells you how the data is, see here, presented in tabular form. It tells you all of that. And here are your tables I mentioned, D1, D1.1, D1.2, et cetera, et cetera. Those are tables, actual tables that are inside OSHA, and we're going to be looking at those. And this to information, let's see, I'm getting ahead here a little bit, need to slow down. So each table represents the maximum vertical and horizontal spacings that may be used with various aluminum member sizes. Remember, you'll have uprights, they call them. They're long, thin rectangles, and one for each side of the trench, and a hydraulic cylinder between them pushing against the wall of the trench. And I'll try to get a better picture. We will get a better picture. And all of these tables are typical of types A and B soil. I think that's the only 2 kinds of soil that we have within these OSHA. And in your assignment, there is a C60 soil, which I don't want to go into right now, but it's similar to Class C. So types A and B soils, table D, 1, 3, and it tells you about that. I want to move on. Basis and limitation of data. This is the kind of aluminum that is used in the shoring. You would go to ANSI to see what that is, or ASTM, let's see, American Society for Testing Material. That will either be, talks about probably the strength of the aluminum. Hydraulic cylinders specification, and we got 2-inch cylinders shall be a minimum 2-inch inside. This is just describing what your cylinders have to be. The inside diameter, 2-inch inside diameter, with a minimum safe working capacity of, there's that 18,000 pounds actual. And that's like mashing, they won't crush. compressive load at maximum extension. That's when they're fully extended, because you know they have this fluid that's environmentally safe, and it's also not water. It's got a little water in it. So the maximum extension is to include full range of cylinder extensions as recommended by the product manufacturer. So you in a way you're kind of figuring the manufacturer knows what he's talking about, but you see there is 18,000 pounds. If you are in some soil that's going to have I can't remember what that tons per square inch or pounds per square inch. If you have a soil, you know that's going to, the walls are going to be, the type of soil that's going to be greater. You're expecting more force against your shoring than 18,000 pounds. You got to stop what you're doing and say, wait a minute. Uh, Full range of cylinder extensions as recommended by the product manufacturer. 3-inch cylinders should be a minimum 3-inch inside diameter working capacity of 30,000 axial compressive. And what does it say? Limitation of application. It is not intended that the aluminum hydraulic specification apply to every situation that may be experienced in the field. These data were developed to apply to situations that are most commonly experienced in current practices. Uh, and here we go back to 26652C, which talks about mechanical system. I'm trying to get out of here. Just telling the contractor or the competent person to use these tables to come up with the size member cylinders and depths and maximum widths and depths of the trench that you're describing. Footnotes and journal notes, that's under G, paragraph G. It has a couple of them, and your tabulated data will most all will have notes. Usually it's going to be similar to these. G1 and G2 is a real common note in each piece of tabulated data. So it's telling you where to go within the 652, 26652 to find out information. It's 2-inch diameter cylinders that shall have structural steel tube 3.5 by 3.5 by an eighth, basically. Over sleeves. See what's happened here? They have a note. Now you got aluminum. Now you're going to have to go to steel with a jacket, I call it. It's an oversleeve or structure. Oh, there it is. Oversleeves of manufactured. In other words, it's reinforcements or a wrap of more steel around the cylinder. Okay, so here we finally get to moving toward tabulated data. This is aluminum hydraulic shoring. This is typical installations. Right here, you can see this upright is what I call them, and so do other people, is vertical. And here's the one up against the other side of the trench. Here's a cylinder, and here's your cylinder. And these cylinders are pushing outward, both of them. Now, when you get over to figure 2, you can see it's talking, it talks about the horizontal spacing. How far in your trench can you be apart with these things? If your trench continues on and your tabulated data is recommending 4 feet, well, this has to be maximum, it has to be no more than 4 feet, because the closer together, the more shoring you have, the stouter you're going to be. But that's all been calculated. Over here, you can see that these are maybe closer together. I don't see the soil type mentioned yet, but my writing's pretty small. You know what? Am I? Whew, what a difference. Well, it's still real small. Can't read it small, really. So here are whalers. Whalers are horizontal. Do you see how that it's the same thing design, but it's put in, let's call it sideways, horizontal. These are vertical shores. These are horizontal, but they're not called shores. They're called wales, not whales, whales, wales. And the same kind of deal, you're going to have tabulated data on whales to tell you what this distance is right here, and then your cylinder size and so forth. And here you have uh, sheeting. That's what that word is going across here. Sheeting sometimes is plywood or manufactured thing, flat piece of material called finform that keeps the sides from raveling. Raveling is when dirt kind of starts sloughing off or gravel starts falling out of the sides of the trench. That requires, I think we have one problem that does, I put in it that to expect raveling, and so they'll have to put sheeting up in there, and then it'll have a note talking about sheeting. Uh, but this is the configuration. This is typical. Notice over here that you have this situation going on, but from here to here, you see how there's an overlap here? That's kind of, this one's down low and it's a little bit further in that direction. This is a little higher and it goes over here a little further, and then you'll have another one. You can see this one's over a little bit. So they're alternating to put more surface against the trench, yet not have to have a solid sheet of plywood or something, because they're not expecting raveling in here, I'm assuming. So, where are the, here we go. Example 1. I call them in your assignment scenario 1. A trench dug in type A soil is 6 feet deep and 3 feet wide. So we're at type A, right? We have a 6 foot deep. We go depth of trench, so 5 to 10. So let's stay right here. So we're 6 foot deep and we're 3 foot wide. Let's go over to width of trench in feet. So we can, if it's over 8 up to 12, you need 2-inch diameter cylinders. If it's 12 and up, you need 3-inch diameter cylinders. Notice there's a note here. See Appendix D, item G2. That's the one I just read a while ago. I forgot what it said, but it's it's up here. We just read it. It's a common note. I forget what it talks about, but you've got to find what it talks about. Uh, I don't think it's going to affect your assignment, but do you get the idea that I give you the specifics of the trench? You have to go right here. Gives you the clue to go to type A soil. So we go to D 1.1, and this is kind of generic stuff here. This is just in OSHA. I don't know if there's a real trench somewhere, you know, like that. But if it is 6 feet deep, if it is type A, and you go over 5 up to 10 feet, you will have maximum horizontal spacing of your what am I trying to say? Of your cylinders, you know, where of your uprights, not your cylinders. Over here, it calls for you're still in this row, and now we're in the maximum vertical spacing, which is like I showed you up here, vertical spacing, vertical. We're not in Wales, we're in hydraulic shoring, but this one, the distance from here to here is what it's talking about now. It's 4 feet in this case, and you'll need a 2-inch diameter cylinder because of the width of trench found 3 feet. So width of trench, where'd it go? Where'd it go? Where'd it go? Depth of trench, width of trench, up to 8. So we need a 2-inch. If the width of the trench was 8 up to 12, we would still be get by with 2, but if it's over 12 and wide, we got to go to a 3-inch diameter. I think you got that. Here's another, I think, deal. Here's a table D 1.2, soil type B. So look here, down here, trenches dug to type B soil that does not require sheeting. I think I have one in here that does. I don't think it makes much a difference in here, but it's 13 feet deep and it's 5 feet wide. So we go table 1, 2, we find the vertical shores and 2-inch diameter cylinder. They're telling us that's what we're going to find. Spaced 6.5 feet apart. Let's see. Let's get depth of trench first, 13. So depth of trench is, here's 5 to 10. Here is 10 to 15. So here we are. So the maximal horizontal spacing of our uprights is going to be 15. No, yeah, 6.5 feet. I'm sorry. Up to 15. Depth of trench 10 to 15. Our depth is 13. So our horizontal spacing of uprights is going to be 6.5 feet. That would be from here to here, 6.5 feet between those. The vertical spacing will be, am I in the right place? No, here. The vertical spacing is going to be 4. So that would be about the same as we had here. 4 feet vertical spacing. Now then, let's keep going to the width of the trench is up to 8 feet. You can use a 2-inch diameter, 8 feet to 12. You can stay with a 2-inch diameter, but note 2, I remember now, says that talks about you got to have a steel cylinder with a sleeve to 30 pounds, 30,000. No, not on this. 3-inch right here will have to go to 30,000, but it'll have a sleeve if it has that note. We only have the note here, so that's only if we have 2-inch cylinders. If we have 3-inch cylinders, we don't have to have that steel sleeve or jacket, as I called it. Let's see. So that takes care of that. I think I have one more for us to look at. This is a Whaler system, and again, let's know what we're looking at right here. It's doing the same thing here, it's just horizontally in place. So let's see if we can figure this one out. Okay, a trench dug in type B soil. Is this what I just did? No, this is Whaler Systems type B. Trench dug in type B soil. I don't see there. Oh, this is for soil type B. Okay. A trench dug in type B soil that does not require sheeting. Am I going to be good here? Let's see if I am. That does not require sheeting, but does experience some minor raveling of the trench face. The trench is 16 foot deep, 9 feet wide. From table D 1-2, that's talking about this up here. So that's not what we want. We want this one. This is 1-3. Where is the example? Well, they're calling it force not, but let's see where is the table? 1-1.3 D 1.3. Let's see here. This is our Whaler system. This is the problem for the Whaler. A trench dug in previously disturbed type B soil. So we've got disturbed soil here. That makes a difference. Usually they'll make you go ahead and change it to Class C. Oh, they did. With characteristics of Class C soil and will require sheeting. The bins, if it's wet in the bottom of the trench or something, they'll change it to Class C, or you will, and then act accordingly. In this case, if it's disturbed, maybe they change it to tab C, because it says with characteristics of Class C. And even though we're in type B, We got to pay attention to this Class C, and will require sheeting. The trench is 18 feet deep, 12 feet wide, 8-foot horizontal spacing between cylinders. So we've got vertical shores, or uprights, and probably sheeting to consider. In other words, we'll have a situation like this, but we will have plywood behind those. Or do we have wells? No, no, wait. Let's see. Where am I? No, it's a Whaler system, so we're going to have this configuration right here with sheeting because it's experiencing raveling. So let's go back down here and see if we can sneak up on this one. Let me make sure I'm back. We're in D1. 1.3 tells me I'm in the right place. So the trench is type C. It is, where's the depth? It's 18 feet deep. So let's get the depth of the trench. Something's wrong with this. This doesn't have it. This one is messed up on me. It got moved. Was moving these tables around, and somehow this one didn't work out. That's okay. I think we got enough. Let's see if this one. I'm not sure. I don't have an explanation. It just didn't work out for us. This one's not highlighted in yellow, so I don't know what to expect from it. Let's see. I'm at 1.4. Let's see if I can find what the scenario right here from table D 1.4. Find horizontal wale with a section modulus of 7. Now, a section modulus is the thickness of the whalers. If you cut a cross section and looked at the modulus, you would have 7.0 and half, 7.0 and half inch diameter cylinders. I'm not sure. This section modulus is the thickness of the metal with the square inches of the, like you cut a whaler in two and looked at it from the side, a cross section. So let's move on and see what we can come up with on this. Find horizontal wale, the section of, let's see, if we got a heading, I don't have to have a good explanation. Let's get the depth first of the trench. Am I in 5? Yes. The trench is dug type 9 foot deep. So depth of trench is 5 to 10. So that puts us here. The vertical spacing is 4. The section modulus is 7. So I got to have a section modulus inches cubed. It's like an area times the length, like of a section of the whale system. So it's the section modulus in cubic inches, and that'd be the width of it, the thickness of it, times the length of the whale itself, and that would be 3.5 and 7 here for this right here. I'm thinking 3.5, 3.5, 7. Horizontal spacing is 6, 6.5. The this is in here. We're still here. The cylinder diameter is 2 inch, and no, this is yeah. Horizontal spacing here is 6.5 and 6 up here, and 2 inch, and it has that note too, which it's got to have a sleeve. And then we get into horizontal spacing here, 6, and then cylinder diameter 3 inch. no notes, but the sheet is 3 by 12, and maximum horizontal spacing on center of the timbers using timber uprights instead of aluminum is the solid sheet is 3 by 12, 2 foot, 2 and 3 foot. That is the uprights, 2 foot and then 3 foot. I don't know what something's out here, but that's all the time I want to spend on this right now. There's more I'd like to get to. Let's see if I can get out of here. But this just gives you a little bit of an idea of what the tabulated data is about. Let's see what else I've got in here. This is your assignment here, using that. And here's the tailgate. Now, look at what I'm talking about. Elements of manufacturer's tabulated data. And I want you to manufacture tabulated data for shoring system typically includes critical elements to ensure the safe and efficient use of shoring equipment, so on and so forth. Feel free to search for relevant information outside of this course. If you use an outside source, please do not copy and paste. Try to put it in, like I said a while ago. There's a lot of information on this out there, but this is the basic. What following the tailgate requirements discuss the following three items: general information, technical specification, usage guidelines. Guys, if you don't have usage guidelines, find something else. It'll be there. There'll be that tailgate fodder thing and that one understanding tabulated data that we looked at before. That one's full of stuff you can put in here. I need 3 posts. Most tabulated data will have a general information. Technical specifications could come in a different way. Usage guidelines may be within the general information, but I need 3 posts. So find something in that tabulated data that you can talk about, uh, and get familiar with it. If I don't care where you get the information, as long as it comes from a reliable source, just do the best you can with that, and I think your grade will. I think you'll do all right. Most of you, excuse me, can write really well. But I said at the beginning, I'm really interested in what you know, what you've learned, and I can when you start talking, telling me the whys. I know if you just tell me something's important, you know that. Of course it is, you know. So tell me why. Okay. Let's see. I think that's all we got on this. I want to make one little trip back up here. I don't want to see what I did here. That's the tailgate. This is the assignment. Oh yeah, this is kind of good. Here's where you're gonna get. This is your little scenario, and then somewhere you find a way to submit me, you know, what you're choosing in here. Uh, this is your soil, 6 foot deep. Just tell me. Select the maximum width of the tree. This is easy. It's just a table. Read it, you know, and tell me what you find. But this, I want you to talk about if you do have notes. Find those. You can go back to that, the tabulated data that we, understanding tabulated data tells you all the references of where this stuff can be found. If you go back and look at the table D, you will find and go to paragraph G. There's G1, G2, and that's what most of these notes are about. I got all the notes down here, and I believe if you read through here, if notes will be referring to G1 and G2 a lot. But this looks like it's spelled out pretty good. So address the notes if you have notes. Okay. Other than that, I'll see you in at some point.